It's been almost 55 years since the first moon landing, and unfortunately humans have yet to walk on the surface of any other celestial body. But that doesn't stop us from dreaming. Even though the first manned missions to Mars won't occur for at least another decade, both NASA and China are looking forward to sending people to Mars in 2033. While history would tell us there's a good chance of that date getting pushed back, it doesn't hurt to be prepared. For over 20 years, private and government entities have been constructing Mars analog habitats to simulate various aspects of what astronauts will have to deal with in their lives on the red planet. Most of these experiments have been relatively short, with crews often inhabiting the simulated stations for months or less. The longest such project was Mars 500, a set of 3 missions culminating in a 520-day experiment. However, Mars 500 was designed to simulate the entire round trip of a Mars voyage, with most of their time being spent in a simulated spacecraft rather than on the surface of Mars. Unlike other Mars analog missions, Mars 500 wasn't really destined to simulate a Mars-like environment. It was also a joint venture between Russia, China, and the European Space Agency, which means it wasn't important because there weren't any Americans involved. But, so not wanting to be outdone, NASA created their own project called CHAPIA, or Crew Health and Performance Exploration Analog. Their first mission, Mars Dune Alpha, just begun on June the 26th of this year. 4 crew members entered a habitat designed to simulate life on Mars, and they are going to remain there for 378 days. It is the longest mission of its kind. But what exactly does NASA have planned for their analog astronauts? Well, let's find out. Now, the goal of Mars Dune Alpha is to simulate exactly what a habitat on Mars might be like and how a crew will handle living there for extended periods of time. After all, what's the point of sending people to Mars if they aren't going to hang out there for a little while? Sure, the longest single moonwalk is just over 7.5 hours, and the longest cumulative excursion time on the moon's surface is only 22 hours, but the moon is only 3 days away. It's the spaceflight equivalent of running to 7-Eleven for a Slurpee. We could go there anytime we want, we just haven't felt like it for the past 51 years. By comparison, it will take about 7 months to get to Mars, and if we're going to send people there, we'll want them to be able to spend considerably more time on the surface to get as much out of each mission as possible. To that end, we'll need to be able to build a habitat on the planet that the astronauts can live in. The simplest way to do this is through the use of 3D printing. The Jacques Ingalls Group, VIG, partnered with construction company Icon to design and 3D print Mars Dune Alpha using Icon's Vulcan 3D printing system. The habitat was printed using Lavacrete, Icon's proprietary cement-based mixture. With a 1,700 square foot interior, Mars Dune Alpha is about 15% smaller than the average single-family home in the US. On one end of the habitat are the crew's sleeping quarters. In a dramatic change from previous analog habitats, each crew member has their own quarters rather than communal sleeping quarters. Granted, each of these rooms is about the size of a solitary confinement cell, but it does give them privacy and the opportunity to decorate and customize their quarters as they desire. Across the hall from the crew's quarters is a full bathroom flanked on either side with small areas for growing crops. Each of these crop areas is only about 5 feet by 6 feet, minus the width of the hallway. Despite their proximity to the toilet, there does not appear to be any indication that it will be used to fertilize the crops. Moving past the crops leads to a large open area featuring both a kitchen and a recreation area, complete with lounge furniture and a 55-inch TV. At the end of this communal area is the main workroom with computer terminals and a 3D printer. Rooms on either side of the workroom contain a gym, a second bathroom, a small medical bay, and a robotics control station. And that small space is where the 4 crew members will spend the majority of the next 12.5 months, living and working together in extremely tight quarters. The only other scenery they'll experience is past the work area and outside the ship's main airlock, where crew members can go for simulated Mars walks while wearing spacesuits. The area outside the habitat is a 1,200 square foot sandbox filled with red sand to simulate the surface of Mars, with murals depicting rocky Martian landscapes on the wall. The entire thing is contained within a hangar in NASA's Johnson Space Center in Houston, Texas. At this point, your mind might be filled with all sorts of logistical questions. If the habitat is 3D printed, how is it also fully furnished? How are they able to breathe inside the habitat without spacesuits? And there are plenty of questions about how this structure would actually be constructed on Mars, but they're not really important for this mission. This is the first of 3 year-long missions planned by NASA, and at least at this stage, their focus isn't on any of the technical considerations of a voyage to Mars. Now, the crew of Mars Dune Alpha consists of 4 people, each with their own specific role. Kelly Haston, a biomedical research scientist from Canada, will be acting as the team's commander. Ross Brockwell, a structural engineer from Virginia, is the flight engineer. Nathan Jones, an emergency medical physician from Illinois, is the crew's medical officer. And finally, Anka Solaru, a microbiologist in the United States Navy, originally from Morania, is the science officer. While each crew member has jobs to do related to their role on the team, the main purpose of this mission is to study their physical and psychological health over the course of the year and any effects that those will have on the crew's performance. And there's plenty of reasons to believe that such problems could arise. The Mars 500 mission saw 4 of the 6 crew members suffering from sleep and psychological problems. In only 3 months, productivity plummeted, with crew members spending an increased amount of time in bed. And the problem only got worse the longer the experiment went on. The situation the Mars Dune Alpha crew will be living in is also very similar to what many people experienced during COVID. They have 4 people living in a space somewhat comparable to a single family home, but otherwise isolated from the world. The sharp increase in overall stress and other psychological problems that swept across society was something few people would have predicted before the pandemic actually happened, especially given our ability to communicate and video chat with one another from anywhere in the world. But that's a luxury that this crew isn't going to have. They will be able to contact Mission Control 24 hours a day, but all communications will be on a 20-minute delay to simulate what actual communication from Mars would be like. They also have the option to communicate with friends and family, but only through email and video messages sent on a delay rather than real-time conversations. The only communications any of the crew members will be able to have that aren't on delay, other than talking to one another inside the habitat, are private conferences with medical professionals who will be monitoring their mental and physical health. The crew will also self-administer questionnaires regarding their mood and temperament on a regular basis. In addition to the stress of isolation, the mission is designed to replicate the experience on Mars and all the other sources of stress that will exist. While they have access to running water, the water for each crew member will be heavily rationed. They will also have to survive eating almost nothing but reconstituted dehydrated food and whatever produce they're able to grow. There will be limited amounts of fresh food delivered in infrequent cargo resupply missions, though it's unclear how often these will occur or how much food they will receive. So there is already the isolation, the other environmental stresses, and the jobs that each crew member needs to perform, but NASA plans to push these crew members further. Though they haven't published the details of exactly what this will entail, NASA plans on putting the crew through simulations of unexpected problems and emergencies that may occur in an actual Mars habitat. Throughout all of this, NASA will be focused on any psychological changes that could be dangerous on such a long-term space mission. Depression, increased irritability, and changes in eating and sleeping patterns are all potential effects of isolation that could endanger a crew. To combat this, it's recommended for the crew members to create and follow a routine that will not only focus on completing their assigned jobs, but that includes socialization with one another and correspondence with friends and family. Now, there's a lot more to a successful manned mission to Mars than just making sure we have the necessary technology to send people there and back. The human factor is equally important, as either a single crew member facing psychological problems or broader sociological issues within the crew can spell disaster for a mission. While earlier analog habitats such as NASA's Hawaii Space Exploration Analog and Simulation or HI-SEAS program focused more on mission-oriented interactions between the crew, Mars Dune Alpha is focused almost entirely on mental and physical health in the Mars-like isolation of the habitat. As important as these experiments and the data that will be collected over the coming year may be, no simulation on Earth will be able to compare to a real mission to Mars. The crew may have to exercise multiple hours each day, but they won't actually be suffering from atrophy and the other negative health effects of microgravity. Their water may be limited and heavily rationed, but they're still able to take showers. This wouldn't be possible in space, as water doesn't flow in microgravity, and they'd have to use washcloths and rinseless soap like astronauts on the International Space Station. It may seem like a little thing, but for many people, going over a year without a proper shower would be absolutely maddening. But most importantly, the 4 crew members are essentially volunteers. If any of them really wanted to, they could leave at any time, and they are unlikely to ever be in real danger. If something were to go genuinely wrong, NASA would evacuate the crew from the habitat. That's even happened before. In the final mission for the HI-SEAS program, one of the crew was accidentally electrocuted only 4 days in and had to be rushed to the hospital. The entire mission, which was supposed to last for 8 months, was called off. Had something like that happened on a genuine spaceflight, the best case scenario would be that they were short one essential crew member while the person recovered. The worst case scenario would be that they either had to live with a corpse in their habitat until they could bring the body back to Earth, or just dump the body out the airlock. The crew of Mars Dune Alpha is certainly aware of the realities that they are volunteers and in no actual danger, at least subconsciously, and that has a huge psychological impact. When things get really tough, they get to choose to keep pushing forward for the benefit of science and to prove that they can do it. Even when NASA puts the crew through simulated emergencies, none of them should ever have to fear that if I up, we're all dead. None of this is to diminish how challenging a situation the crew has been placed in or the importance of this research, but it's also important to acknowledge the significant role that having such a big safety net will play in the crew's ability to handle various stresses throughout their year in the habitat. Any negative psychological effects they experience in the habitat would almost certainly be magnified in an actual mission to Mars. But for now, all we can do is wait for this mission and Chappia's subsequent missions in 2025 and 2026 to run their courses so that we can see what the data shows. Of course, while we wait, it may be a good idea if somebody actually does try and figure out all of those logistical issues from earlier in the episode that we kind of just ignored, like spaceflight and such.